Arithmetic series. Yes, we are working with the sum of terms in a arithmetic series. We have got two different equations. Remember, the first one is the sum equals the position divided by 2 multiplied with the sum of the first and the last term. We, however, have a second possible formula of which we must know both in this case. And remember, in the previous videos, I taught you the short way to remember this. That is Sn equals n over 2 times 2tn. Okay, because a plus d times n minus 1 is tn. Okay, so both of these formulas you must know for arithmetic series. That is why it is so really important that you identify your given information, because that will determine which formula to use. Now with this example, it's a bit more complicated, so let's go through slowly. Okay, they say find the sum of the arithmetic series 3 plus 6 plus 9 and so forth plus 300. Right, so if they watched the previous video, you will now already know the rhyme for the variables that we must identify. We said it's SNN, ALD, where the first four are from my first formula and the D is the only different variable in my second formula. So let's start to identify. They say find the sum. So Sn is being asked, all right? Then we need to get the number of terms. And if we look at that, we actually don't know. There is a whole lot of terms here which we don't know how many there are. So n is also a variable. Once again, immediately people, we have a problem because Sn and n are both in both formulas, all right? So already you should start thinking. Let's go on identifying. A, the first term we've got as 3. L, the last term is really 300. Right, but we have a problem using Formula 1 because we've got two variables. Now let's look at D, all right? The common difference, which we can work out because we just simply take one term and subtract the previous term, which gives me 3. However, if we look at this, people, then we still have two variables, okay? And we only got one equation. We don't have two equations that we can work it out with simultaneous equations. So now this comes to my mind, right? I cannot solve this. But what you should also realize that the 300 is also the nth term. Okay, so when I now look, I now have the variables for Tn, isn't it? Because my formula for Tn is A plus D times n minus 1. So let's check whether we can actually find all the different variables. We can find Tn, we can find A, or we already got A, then D, the difference, we have calculated, and then only n remains the variable. Okay, and when I've got n, when I work this out, people, then I can use my first formula, isn't it? So now let's work with Tn. Tn equals A plus D times n minus 1, right? Substitute your relevant information. Tn is 300. A is 3. The common difference is also 3, and then n minus 1. Okay, now we're just simply going to solve, right? Multiply out the bracket. Then we have 300 equals 3 plus 3n minus 3. 3 minus 3 gives me 0. So 3n equals 300, which means I must take over the 3. Remember, we are just simply going to solve the linear equation with one unknown. We want to find the value of n. So that will give me 300 divided by 3. So n equals 100. And now importantly, people, here I now got 100. Okay, and if you then go back to your first formula, then the sum is being asked, okay? The sum is being asked. But now I've got a value for n, I've got a value for a, and I've got a value for L, the last term, which means I'm going to take my first formula, which is Sn equals n over 2 times a plus L. So the sum is being asked, that will remain Sn. We have now just calculated the position, which is the hundredth. Divide by 2, substitute the a as well, and the L, which is 300. Okay, and then if you put this right hand side into your calculator, you will get a final answer of 15,150. So the sum of this series, starting at 3, having a common difference of 3, ends at 300, okay, and their sum will be 15,150. Okay, this is a bit more complicated, so I will go through once again. We have got our two formulas, right? We then have identified our different variables. Remember, for the arithmetic series, we remember the rhythm SNN ALD. Okay, SNN ALD. Okay, the sum is being asked. We do not have the position. We do have the first term. We do have the last term. And we can calculate the common difference. Right, this gives us a problem because we've got two variables, all right? So I can use neither equation 1 nor can I use equation 2. But then I must realize that my last term, which is 300, is also the nth term, okay? Which brings me to the formula of the arithmetic sequences. Now, the nth term for an arithmetic sequence. And if you now check your variables, we've got Tn, we've got A, we've got the common difference, which means we can calculate n. So that is my first step. I use my formula for the arithmetic series, okay, the nth term. I substitute my values, and with that, I calculate how many terms will be in that series, okay, which is 100. And if I then enter my calculated answer into the place of n, then I can see that I can work with my first formula, because now I only got one variable left, which in fact is the sum, and the sum is the one that is being asked. So then we go to my second formula, which is the sum, right? And I substitute the use the first formula, okay? But you use that as second step. So use the sum, all right, which is n over 2 times L plus D. Substitute your values, calculate your right-hand side, and you will get 15,150.